Good morning, everyone, and welcome to Spring Clean and our live lesson for day 3. What would be lovely to start with would be to start with a quiz, just like we've been doing in the past few sessions. And don't worry if you weren't able to join the last few sessions, you can still have a go at the quiz. So our first question, true or false? Information about you that is posted online affects your rights under the UN Convention on the Rights of a Child, the UNCRC, and that's something that we've been speaking about earlier on this week. So if you think that is true, put your hands up, and if you think it is false, put your hands on your head. So information about you that is posted online affects your rights under the UN Convention of the Rights of a Child. Hands up for true, hands on your head for false. And we've got lots of answers coming in, and you are all saying the same thing. You're all saying true. And yes, congratulations, you are correct. It does. It affects your right to privacy or privacy, and it also affects your right to protection from abuse. Excellent answers, everyone. Well done. Okay, our next question. What fraction of 5 to 7-year-olds are using social media despite the age limit that is set for most of these apps being 13 years old? So if you think about a quarter of 5 to 7-year-olds are using social media, then put 2 hands up. If a third are using social media, put 1 hand up. And if you think it's about a half, put your hands on your heads. And teachers, if you can just give us the roughly the biggest group that you're seeing in your class, then that would be brilliant. So 2 hands up for about a quarter, 1 hands up for a third, half, hands on heads for about a half. Lots of answers coming in. Most of you are saying a third. It's almost as if we've done this lesson before. Well done. Yes, it is around a third of 5 to 7-year-olds are on social media, despite there being an age limit for most of these apps, which is 13 years old. Thank you for those answers. Well done. I can see that our brains are working this morning. So just a reminder that this week we would like you to adopt a place. So to do this, we want you to find a local place to look after for the week and hopefully longer. And then we also want you to think about how you want to look after it. And then we want you to take a photo of your adopted place and send it to us and tell us what you think is important about it and why we need to keep it beautiful. And then you can submit it to our competition. And your photo could end up in our Keep Scotland Beautiful calendar, as well as winning £25. And all photos submitted by 2 p.m. tomorrow on Thursday will be included in our assembly on Friday. And we want you to spring clean your adopted place and the surrounding area by organising a litter pick and record how many bags of litter you collect and enter our litter league. And whoever collects the most litter will be crowned regional or even national litter league champions. And all the resources to this can be found on our website. But what do you need for today's session? Well, you might want to have a pencil and a pen and a calculator handy for some parts of today's lesson. So I'm just going to give you 30 seconds or so to begin gathering those things if you would like them. Okay, hopefully some of you have got some of those things to hand, because what you're going to be doing today is you're going to be learning about the travels of a crisp packet, and you're going to learn what happens to single-use plastic after it has been used. You're also going to learn how to calculate percentages, or have a go at practicing how to calculate percentages if you've already done this. And you're also going to be having a think about how to design environmentally friendly packaging. And what we want you to do is we want you to imagine you are like these people in the picture. You're material scientists, and you are trying to design a better option for packaging crisps. And towards the end, after you've learned about different types of crisp packets and recycling and things like that, we want you to write a wish list for a brand new crisp packet design. But that's all from me for the introduction. I'm going to hand over to Nicola now, and I will see you all at the end of the session.
Thank you so much, Josh. So welcome, everybody. So I'm really excited today to be taking you on this journey of a crisp packet. So we're going to follow the travels of our imaginary crisp packet and see where it could end up, and maybe think about what we could do to improve things along the way, just like Josh said. So the first question is quite a simple question, really. What percentage of your class likes crisps? So some of you might have calculated percentages before. For some, this might be new to you. So I'm going to put the calculation up of how you calculate a percentage. So what we need to do is count the number of people who like crisps. We divide it by the total number of people of what we're counting and times by 100. Now, if you've not done percentages before, or you're not a bit sure about them, what you might want to do is count how many people like crisps out of the nearest 10 people to you. So you're going to count how many people like crisps out of 10. You're going to divide the top number, so the number of people who like crisps, by 10, and then times it by 100. If you want a bit of a trickier version, then you're going to count out of the whole people in your class. So out of everyone in your class, how many like crisps? Divide that by the total number of people in your class and times by 100. Now, we might get a little issue in that it might be that everyone in your class likes crisps. So if that's the case, I want you to include your teacher, and teachers, I want you to pretend just for today that you don't like crisps, just so we don't get lots of 100% to make the calculation just a little bit tricky. So if you can do that for me now, take plenty of time. So say you need to count, if you want the slightly simpler option, if you're not so sure about percentages or you've not done them before, count out of the nearest 10 people, how many people like crisps. If you want a slightly trickier option, out of your whole class, how many like crisps, divide that by the total number and times by 100. Oh, and I can see some answers coming in. Excellent calculations are happening. 84, 86, 88, 96. Oh, we do have 100% from Mrs. Connell's class. Oh, it's a big high number, isn't it? I think, let me see, what's the lowest number I've seen so far? I think 86 or 84 was the lowest so far, 91.3. Oh, we're getting into fractions there. Excellent work, Miss Bruce's class. 95, 92. Excellent work. Oh, 77. So Miss Vivey's class are a little bit less keen on crisps, which is absolutely fine. 90% again. Brilliant. So we've got a kind of quite a high percentage overall of people who like crisps. So we know that then lots and lots of people like crisps. So that means we're going to go through quite a lot of crisp packets. Oh, even more coming in, another 100% and 77, 95. Brilliant work, everyone. Really good work on calculating those percentages. So we know lots and lots of people like crisps. We're going to have a lot of crisp packets. So all of those people who like crisps, you've had a very tasty packet of crisps and you've eaten them all. But now we're left with an empty crisp packet. So now what happens? So I want you to tell me what could happen. I've got an empty crisp packet. What different things what could I do with that crisp packet? And you can think of not so good things I could do with this crisp packet as well. Maybe think of what would be a good thing and what would be a not so good thing that I could do with this crisp packet. And then we're going to follow the different journeys that you come up with. So what could I do with this crisp packet now it's left over? What do you think? Oh, brilliant. So Ms. Bromley's class says put it in the grey recycling bin. Yeah, so we could put it in a recycling bin. Brilliant. This Albert's class also saying recycling it. That's a really good thing that we could do with our crisp packet. And Ms. Bromley's class, yeah, not so good thing. We could throw it on the ground, couldn't we? Someone else is saying putting it in a normal bin. Oh, wow, let's see. Yeah, throw it in the road, put it in the bin. Put it in the recycling bin. Oh, and I like the idea for Mrs. Mills' classes to make something out of it. And maybe wash it out and reuse it. So yeah, we could do something like reusing it. That's something that we can do. And as long as whatever we reuse it for means it's still recyclable, then that's okay, isn't it? Brilliant. So generally we're getting the three main ones though here, aren't we? So we could put it in a recycling bin. We can put it in a normal rubbish bin, so a non-recycling bin. Or we could just throw it down. And some people have already thought about what could happen if we do that, because I can see some people saying about what could happen if we drop it as litter. So we can put it in the recycling bin, put it in a normal bin, or we could drop it as litter. And I want you to tell me, of those three journeys, which one do you want to follow first? So we're going to look at those three things because that's the most common ones you guys have come up with. Which one do you want to follow first? So if you would like to look at a crisp packet that's being recycled, I want you to put one hand up. If you want to put it in the bin, put two hands up. And if you want to see what happens when it's littered, put your hand on your head. So we're going to do, this is you want to follow a recycling journey. This is you want to follow a bin journey. And this is you want to follow a litter journey. And we will get to all of them, but I want you to pick which one we do first. So if you can see what the majority is in your class, and we can put it in the chat. We've got quite a few want to see what happens to a litter. A few want to follow recycling, quite a lot saying litter. Okay, so I think at the moment, the majority are saying a litter journey. So I say, don't worry, those who voted for the other options, we will come back to those, but I want to give you guys the option to do that. So what we're going to do is we're going to follow what happens if this piece of rubbish is dropped as litter. Brilliant work. Thank you, guys. So let's follow the journey of a crisp packet after it's been dropped as litter. So obviously we don't really want to drop packets as litter because what can happen to them? So we're going to follow, hopefully you can see I've got my wee crisp packet down in this little right hand corner here. And we're going to follow what happens to it on its journey. See if you can have a look at this and think about, just in your head, think about where this crisp packet might end up once it's being dropped outside this person's house. So it's starting to go. So maybe the wind picks it up and blows it out of their garden. Oh, and it's going to get blown around a bit. And now it's heading off into some trees and it might get tangled up a bit in there and eventually gets washed out by the rain and ends up in the river. And then it heads down the river and out to sea. So when all the way it goes along that little journey, that crisp packet might be encountering lots of different wild creatures. And it could cause harm, couldn't it, if an animal gets tangled in it or tries to eat it. And eventually, just like one of the classes said earlier, that crisp packet could end up in the ocean. So it can go all along this journey. And eventually it could end up in the ocean. And along that way, there's lots of animals that could interact with it and get harmed by it, which I'm sure you're all aware of. But let's think. So this crisp packet has been dropped as litter, and it's slowly winding its way through our natural world. But how long is it going to be there? So does anybody know how long it takes for a crisp packet to degrade or break down? So that it stops looking like a crisp packet and just becomes tiny, tiny little bits that we wouldn't be able to see. How long do you think that would take? Oh, got some answers coming in. 100 years, 50 years, 6 months. We've got a big difference in what we think. 100 years, 20 years, 2 years, decade, more 100 years, 5 years, 10 years, 10 to 50, 80. Lots of brilliant answers coming in here. 5 years. Well done, everyone, because it's quite difficult to know, isn't it? How long do these things take to break down? And it does depend a little bit on where they end up. Or another place in saying 500 years. Well, it can actually take, and it does depend on where the crisp packet ends up, but it can take about 80 years for a crisp packet to degrade. So I was born in the year 1983, which is a long time ago for some of you. But I was born in 1983. So if I put a crisp packet, if I dropped that as litter, someone dropped it on the day I was born, so in 1983, what year do you think it would break down? So I was born in 1983, and it's going to take 80 years for it to break down. You can maybe use your calculators or try to see if you can do that sum in your head. So 1983 plus 80 years. What year is it going to break down eventually? Oh, lots of answers coming in. I can see all correct answers, which is brilliant. Some good maths happening today. So yeah, looking really good. So everybody who said, I'm just going to give everyone a wee second just to make sure you've had time to do that in your heads or on your calculators. Yeah, so pretty much all of you are saying 2063, and that's right. So that's still a long way away. We're only in 2025. So if someone dropped a crisp packet on the day I was born, it's still going to take until 2063 for that to break down. So nearly another 40 years. And we know this because this is a crisp packet that was found in Aberdeenshire. And it was found in 2020, but we know from the branding and things on the crisp packet that this was 50 years old. So despite being exposed to wind and waves and weather, 50 years on, it still looks quite like a crisp packet, doesn't it? So these things take a long time to break down. But why is that? Because if we're being material scientists, we need to understand, why does it take so long? So what does it take? What does a crisp packet degrade into? So we're going to think about why it takes so long for a crisp packet to break down. So don't answer this question quite yet. We're going to work through it. So why does it take so long for it to break down? So I want you to think about, if you've got something that's a natural material, so maybe some leftover food or an apple core or a piece of wood, how does that normally break down? So if you just dropped an apple core or a piece of wood or something like that in nature, how does it get broken down? Because that doesn't last forever. It gets broken down. What kind of things break it down? Okay, because see, Mr. Eden's class says it rots. Yeah, absolutely. So a rot, what's helping it rot? Does anybody know? Maybe a bit of a tricky question. Yep, someone says animals eating it. So yeah, like the apple core, an animal might come along and eat it, and there's certainly animals that eat wood. And things like, so Mrs. Collins class says soil, sand being moved around. So you've got nature, weather, and wind starting to erode these things and break them down. Weather, animals gets eaten. Lots of brilliant. So we're thinking about natural things like rain and weather. We're also thinking about things like animals. Someone's also said, oh, mold and insects and bugs. So you've all got the right ideas. So when we put these natural things get broken down by things like bacteria, and some people have said mold. So that's a type of, kind of like a mushroom, kind of related to mushrooms, but not exactly mushrooms, but bacteria and tiny microscopic creatures, and also bugs and insects, and maybe even bigger animals for things like the apple core. But basically, tiny little bugs break these things down. So they break all the bits off and they chew tiny little bits at a time. And eventually you have no apple core and no piece of wood left. It's all gone. But someone earlier said that crisp packets are made of plastic, so they've got quite a lot of plastic in them. And plastic, the way it's formed is it's these groups of plastic held together by chains. So it's these little plastic molecules and they're held together by chains. And all those bugs and bacteria can't break those chains down. So these little links that you can see between the circles, they can't break those down. So they can't eat the plastic. And that means that we need to use the other things that you suggested, like weather, things like heat, sunlight, oxygen in the air, and that's what breaks the plastic down. And that takes a lot longer than if some bugs could just come and munch it away. So that's why it takes so long. The other problem is when you break some of these links, so the bacteria, if we eventually break these down with the air and with the wind and the weather, some of these things can be quite toxic. So even if the animals manage to survive getting tangled in the plastic, they're going to be surrounded by these tiny bits that are left over, and some of those can be quite harmful to animals as well. So it's not really ideal to be dropping things as litter, which I know you know already, but this is just some more of the reasons why. So remember that you are a materials scientist and you're trying to create a really good crisp packet. So based on what you now know about what happens to a crisp packet when it's littered, what would you want your ideal crisp packet to do? If someone drops it as litter, because we want to stop that as much as possible, but sometimes people still drop things as litter, or things get blown out of bins even if they've been put in the right bin. What would you think a really good crisp packet would do? How would you design it? You can see a couple people saying disintegrate. Yeah, so maybe we want it to break down, and a lot quicker than 80 years. Yeah, another class saying breakdown. Oh, that's a really good thought from Miss Peach's class. Animals can eat it. So yeah, maybe it's something that even if an animal eats it, it's not going to get stuck. It'll maybe break down in their stomachs, and it won't be toxic. That's a really good idea. So not toxic to animals. Mrs. Milka saying, yeah, naturally biodegradable, so it should break down in nature. Oh, I like Miss Ross's class. Yeah, shrink and disappear. Oh, and I like, yeah, dissolve in water or be edible. Brilliant answers. Someone else saying made out of organic materials, so we can make it out of natural things. Brilliant. So then it will just break down and it won't be harmful. Oh, and I like the idea of maybe making it heavier. So yeah, it doesn't blow away as much. We could think about how we can stop these things becoming litter. Brilliant. Really good answers. So yeah, we want this to maybe dissolve in water, be edible if an animal accidentally eats it, break down. Brilliant. So keep those in mind when we come to our final thing. Oh, and someone else has said reusable as well. That is also an excellent thought, so that we only use a few of them. Keep that thought in mind. Brilliant. So we followed what happens to a crisp packet that ends up as litter. So now let's think about, we said two other options. So it could be dropped as litter. You also said it could go in the recycling bin. And you also said it could go in a normal bin, so not a recycling bin. So what do you want to look at now? What happens to the crisp packet? So you can put one hand up if you would like to follow a crisp packet as it gets recycled. And you can put one hand on your head if you'd like to see what happens to it if it goes in a normal bin. So a recycle one, sorry, follow the recycling journey, goes in the bin. Follow the bin packet. Let's see, you can see some answers coming in. Oh, brilliant. Thank you very much. Quite a few people are saying recycling, another one saying normal bin. All right, so most of us now want to follow the journey of a crisp packet that's being recycled. So I now have a question for you. So let's follow this crisp packet. So we've seen what happens if it gets dropped as litter. Maybe let's follow a better scenario. So this crisp packet has ended up in the recycling bin. So do you know what percentage of our household waste actually goes into recycling? So let's think about how many of these crisp packets are actually going in the recycling in Scotland. So remember, you've done your percentage, and a percentage is how many out of 100. So how many crisp packets or other things that could be recycled out of 100 go in the recycling bin? What do you think? Got a couple answers already. So maybe 20% of what could be recycled. So 20 in every 100, 80%, 59%, 40%. 80. Some excellent answers coming in here. Oh, so we've got quite a big variety. So we're maybe not quite sure yet how many of these things actually go in the recycling. So this is all down to our choice, what we choose to put in the recycling bin, rather than them ending up as litter or in a normal bin. Lots of answers there, 38%, 7.5%, 40%. So a couple of schools have got pretty close. Well done. So the answer is 42%. So that's 42 pieces of rubbish out of every 100 that could be recycled actually go in the recycling bin. So that means that we still throw a lot of things in the general bin that could be recycled, and instead other things are happening to them, which we'll look at in a minute. So that's around 4 out of 10 pieces of rubbish are going into the are going in the recycling. So we could definitely do better on putting them in the recycling. So our crisp packet, our lucky crisp packet, we put this one into the recycling bin. But is it a really lucky crisp packet? Let's have a little think about what happens to it now. So before we look in detail at the crisp packet, I just want to ask you a little question. So when I say recycling, and you all seem to know lots about recycling, which is brilliant, which picture do you think of when I say recycling? Is it this circle, or is it more of a kind of downward spiral? So 2 hands up if you think it's the circle on the left, 1 hand up if you think it's this spiral. So what's recycling? Lots of people saying circle. Oh, very quick. Yeah, so we maybe recognize that symbol we see on a lot of our packaging, don't we? Some kind of circle. And that's what recycling should be. That's where whatever you put in, so when you finished using something like a crisp packet or a can or a bottle or whatever it is, you put it in the recycling bin and then it gets recycled pretty much back into the same thing. So you put something in and it comes out exactly the same. The other side, so the option on the right hand side of your screen, this downward spiral, this is something where we put it in the recycling bin, but because of what it's made of, we can't turn it back into the thing it started as. So each time we try it, so we break it down, we melt it down, but we can't turn it back into what it was because it kind of loses quality when we melt it down. And so it gets turned into something else, which is still useful, which is great, but it's not quite as good quality. And eventually we can't keep redoing this, and we have to put it in the normal bin and it can't be recycled. So you can kind of call that downcycling. So keep that in mind. So when we put something in the recycling bin, not everything goes back to exactly what it was before. Some stuff ends up what's called downcycling. So let's think about what happens to our crisp packet then. Does anybody know what a crisp packet is made of? What do you think it's made of? Any ideas? What kind of materials? If you think about a crisp packet, when you've seen it, when you've touched one, what does it look like? What's the outside look like? The inside, what's it made of? Lots of people saying plastic. Oh, and we've got there Mrs. Hippolyta's class are also saying foil, as Mrs. Connell's class and Mrs. Bruce's class. So quite a few people saying foil and plastic. It does depend a little bit on the type of crisp packet, but most crisp packets, really well done, everybody, are made of plastic film, just like you said, and they've also got an inner metal layer. So quite a lot of you said foil. So it depends on the crisp packet. Some don't have that, but a lot of them are plastic layers with a thin layer of foil on the middle. And someone mentioning tape, so they can have glues and tapes and things as well to keep them closed. Really good thinking. So we've got this plastic film and it can be up to 4 layers. So you think that's a really thin packet, isn't it? But it can actually be up to 4 layers of plastic and foil all stuck together. So it's quite a complicated structure, lots of layers stuck together. So what do you think then happens when we put this crisp packet or other kind of filmy soft plastics in the recycling bin? So when you put that crisp packet in the recycling bin, do you think it gets recycled back into more crisp packets or other kind of soft plastics? Put 2 hands up. If you think it gets downcycled so it can be turned into something else usable, but it's not another crisp packet, put 1 hand up. And if you think actually we just can't recycle crisp packets at all, put your hand on your head. So it goes in the recycling bin, but actually we can't recycle it. So 2 hands up if you think it turns into a new crisp packet. 1 hand up if you think it turns into maybe something else that's not as good a quality. And hand on head if you think actually we just can't recycle crisp packets. Well, we've got lots of answers coming in, and I might have given you a clue by going through this. So some of you think maybe we can recycle it, we can turn it back into a new crisp packet, and quite a few of you think that we maybe need to, it gets downcycled. So those of you who said the middle option, 1 hand up, downcycled, you are correct. Because it's such a complicated material and the way the plastic's made, what happens is that it can't be turned back into a crisp packet. So that's what we'd like to think. When we put things in the recycling, we think, I put a crisp packet in here, it's going to turn back into a new crisp packet. And that's what we really want. But because of what it's made of, we can't do that. So if you put something like an aluminium can, so a drinks can, or you put glass into the recycling bin, it does what the first option is. It can be turned into new glass and new aluminium cans forever and ever and ever, pretty much. But with our the soft plastics, we can't do that. So what happens is they get turned into things like clothes. So you can make plastic clothes out of what once you break down the crisp packet. Or you can turn them into things, you get these little plastic beads, and you can make them into things like if you've seen plastic furniture, things like that. So that's good because that means the crisp packet is not just going into landfill. We can do something with it. But it's not really ideal, is it? Because eventually, when we don't want those clothes anymore, or we've finished with that furniture, that then can't be recycled again because the plastic's just too poor a quality. So we have to then get rid of them and we can't recycle them. So ideally, what can happen is the first option. At the moment, mostly what's happening with crisp packets is this middle one. And some things can't even be recycled at all. Some plastics can't be, but we know crisp packets now, it's good. We can do something with them, but we could be better. So it's downcycled. So now you know that's what happens to a crisp packet. You're the material scientist again. So we're designing our ideal crisp packet. What would you want in this crisp packet? If we put it in the recycling bin, what do you think should happen? If you've designed the perfect crisp packet, what's this crisp packet going to be made of? What's it going to do? Let's have a look. So we've got Miss Amit's class, sorry, saying made with recyclable materials. So we can do something that we can recycle. Someone's mentioning paper or cloth. So maybe you're thinking about some of the materials that we can maybe recycle a few good times. And also paper is quite nice. We can't recycle paper forever. We can turn it into more paper, but eventually it does degrade. But when it goes into the environment, because we remember our littered one, we know it breaks down. So that's really good. That would be good. I like the paper idea. Non-toxic recyclable material, that's a really good idea. And we've talked about the biodegradable, so we want to keep that in mind, definitely. And yeah, maybe something that could be made into other things that we can keep recycling. That's a good thought. Made into more crisp packets. Cardboard, so we've maybe thinking about some other brands that we've seen that maybe have these things that are more recyclable. Oh, someone else said that you can, so things that we can maybe bring your own container. So clothes, paper, make Playmobil with it. Some really good ideas there. So remember, we want to keep in mind, we can make things like Playmobil and things, but remember that eventually we still need to be able to recycle that. We want to close that loop so that nothing falls out the bottom. So we would need to make sure that that Playmobil could still be recycled into good quality plastic. Well done. And dissolving water, so yeah, we need to keep in mind that as well as being recyclable, that it's something that can break down easily if it ends up in the environment. Brilliant. So we've followed our crisp packet as it's gone into the recycling, and we've followed it as it ends up as litter. Now we need to see what happens if it goes into the normal bin. So what do you think happens if our crisp packet goes into the normal bin? Where does it end up? Does anybody know? People, oh, you guys know, you know your stuff. Most people are saying landfill or the dump. Absolutely. So this is where your crisp packet will end up if it goes in a normal bin. So it's off to landfill. So your crisp packet has ended up in landfill. And remember what we said about your crisp packet when it was littered. Oh, and someone mentioned actually, Miss Bromley's class says it gets shipped to other countries. So yeah, sometimes we ship our recycling as well, not just our general waste, but our recycling can be shipped to other countries. And we need to be very careful of that because sometimes other countries might not actually have the facilities to be able to recycle it. So we need to be very careful what we're doing with our waste. Very good, Miss Bromley's class. So this one's ended up in landfill in our country. Now, we thought about our press packet that was being littered. And we said that when it was littered, that it can't be broken down by things like bacteria. It was broken down by the sun and by rain. What do you think might be different about the landfill? Do you think there's a lot, when you put all this waste in here, is there a lot of sunlight and is there a lot of air? What do you think? So down in the middle of the dump, is there lots of sunlight and air down there? Seeing quite a lot of no's. Nope. I like nope. No. So there's not much sunlight and air. It's really dark. There's no air. So the crisp packet can take even longer to break down if it's in the middle of this big dump of a whole load of plastic. So it can take even longer to break down. And someone, Ms. Ross's class also mentioned toxic. Yeah, so you're getting more and more of these toxic things build up as everything breaks down in one big place. So that's not really ideal either. So is there anything else? I think we've probably got things, but is there anything else you want to add to your list based on what happens to a crisp packet in landfill? Let's maybe have a think based on all those three journeys. So it could be go into the recycling bin, but we know it's maybe going to get downcycled. It could be dropped as litter, or it could end up in landfill, and then it needs to break down. But at the moment, crisp packets break down very slowly, and they can be toxic. So now you've got your now you're your material scientist, you're sitting in your laboratory and you're going to write a list. You're going to make a brand new crisp packet. What things are on your list for what this crisp packet must do to be more environmentally friendly? Let's see. So we've got breaks down quicker. Definitely. We want this crisp packet to break down a lot quicker in the environment. We want it to be edible. I really like this idea of an edible crisp packet and breaks down. So we want an edible crisp packet that can break down. Anything else you want on your list? Biodegradable. So yeah, we want it to degrade naturally in the environment, don't we? Which is not happening at the moment. Someone else is saying refill. So that's a really good thought that we can maybe do rather than designing a better crisp packet. Maybe we could look at changing how we do and just do away with the crisp packet. I like your thinking. Simple to recycle. Yes, we want a simple structure so we can recycle it easier back into another crisp packet. Yet no microplastics. So we don't, when it breaks down, we don't want to leave these toxic little microplastics left, do we? Brilliant. Non-toxic, more able to be recycled, dissolve. Brilliant. So that's your job next is you've got to go and find a laboratory and you've got to design this new crisp packet. Now maybe leave it until you've done a little bit more school before you get to that stage. But that is exactly what scientists are trying to do at the moment, is they're trying to make ones just like you say, no plastic is good and natural materials. I really like that. So we can have something that's maybe edible or not toxic to animals, breaks down quickly, not made from plastic, will maybe dissolve if it hits water. I really like that one. And is easily recyclable, maybe back into what it started as rather than having to downcycle it. Brilliant. So like I say, it's maybe a bit in the future for you guys to get involved in the actual material scientist bit, even though you've come up with an excellent wish list for them. So last wee thing is what could we do right now? So a couple people have mentioned we can maybe get refills of things. We don't tend to see crisps in those kind of refills so much, but maybe we should start putting crisps in those. Anything else you think we could do right now? So what could you do to try and maybe reduce this kind of crisp packet waste? So if the crisp packets aren't ideal, how could we maybe have fewer of them? So yeah, we can recycle them. We definitely want to recycle them. So even though these things get downcycled, that's still the best path for a crisp packet. So always make sure you put your crisp packets in the recycling bin wherever you can, and definitely don't litter them. Someone's saying reduce how many crisps we eat. So yeah, you could eat fewer crisps and maybe have snacks that don't come in that kind of packaging if that's possible. Someone's saying, yeah, maybe try and buy them in paper or cardboard wrappers. So that's a really good idea. So here's an option. We could put them, we could try and buy crisps that are in packaging that's called things like compostable or biodegradable that can break down. So that's be a good one. And someone's saying get a recycling bin for your crisps. Yeah, if you can't recycle your crisps at the moment. Oh, Mrs. Dawson's class, you read my mind. So instead of multi-packs, you could buy a big bag. So if you think of a multi-pack of crisps, that's a big bag with lots of little smaller bags in it. That's a lot of wrapping. Whereas you could buy one big bag and then put it into a smaller pot and take that with you and have just a smaller pot from that big bag. So that would be a great way of doing it. And yeah, avoid the single-use small bags. Well done. And definitely don't litter. Yeah, definitely. Brilliant. The other thing that you could do is you could make your own crisps. If you really want to try it, you can find recipes for using potato peelings to make some very tasty crisps if you want to try that. And finally, you could write to people to ask for change. So you could ask for better recycling in your local area. I can see some of you are already trying to get recycling bins in your school, which is brilliant. But you can also write to your local members of parliament to say that you want to see more recycling and you want to see companies change their ways so they're using better packaging. Brilliant. I'm so happy. So many ideas today. Thank you so much for all your help. Oh, and someone's mentioning homemade apple crisps, so I have to read that one out. That sounds great. So thank you so much for all your attention today. You guys have been brilliant. I'll hand back over to Josh now.
Thank you so much, Nicola. That was a really interesting lesson. It was lovely seeing all of your answers coming in. And yeah, homemade apple crisps sound great. I'm going to give that a go when I get home. Yeah, so hopefully you enjoyed that lesson and you learned about what happens to single-use plastic after it has been used. It was lovely to see all of your brains whirring away and seeing you all calculate those percentages. That was really great to see. And yeah, I loved all of your suggestions about the different designs that we could have for environmentally friendly packaging. So hopefully you enjoyed your morning of being material scientists. What we would like you to do next, inspired from Nicola's lesson, is that we would like you to investigate your own piece of litter. And you can find whatever litter that you can find in your local area. And there is a resource on our website which will help you with that. As always, we would also like you to share your work with us as well. And remember, any work that is shared with us can, by 2 p.m. tomorrow, will be shown in our assembly on Friday. And that can be work that includes your litter investigation. And please share anything that you're doing for Spring Clean Week on social media as well. And we will share your posts from public accounts in our assembly as well. I'm just sharing in the chat now a feedback form. So for teachers, it would be lovely for you to share yours and your pupils' feedback on this lesson, what you enjoyed and what you would like more of. And tomorrow, we have got a wonderful session which is looking at the history of community support, and we'll get a chance to meet some pupils who have been working really hard in their local community to reduce waste and to tackle litter. So it'll be lovely to see and hear some stories from them. Also tomorrow, we have also got our Spring Clean Gaelic lesson, which will be the Gaelic version of this lesson. And all that remains for me to say is a big thank you to all of you for joining. Thank you to teachers for supporting us, and thank you pupils for all of your wonderful answers. I hope you enjoyed the lesson as much as I did, and we will see you all back here tomorrow morning. Thank you, everyone, and goodbye.